According to the 2020 National Electrical Code, receptacles cannot be installed above suspended ceilings except for specific industrial or commercial applications as stated in NEC Section 300.22c. If a receptacle is installed above a suspended ceiling for an industrial or commercial application, it must be permanently connected to the circuit, referencing NEC Section 400.8. The suggestion of using a NEMA 1 box and nipple would not meet these code requirements. From a practical standpoint, the hole in the ceiling for the conduit may not be aesthetically pleasing to some. A cord hanging from the ceiling poses a tripping hazard. A receptacle placed on the ceiling may be difficult to reach in use. As an alternative solution, consider using a drop cord with a receptacle that can be suspended from the ceiling when needed. This would provide a temporary solution that meets code requirements and addresses the concerns related to aesthetics. The use of a NEMA 1 box and nipple above a suspended ceiling is not compliant with the NEC and may raise safety and aesthetic concerns. A more suitable solution would be to install a receptacle on the ceiling or use the drop cord with a receptacle. The National Electrical Code is a comprehensive set of standards that govern electrical installations in the United States. It is updated every 3 years to reflect changes in technology and best practices. When planning any electrical work, it is essential to consult the latest edition of the NEC and any applicable local codes. The NEC provides guidelines for various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. It aims to ensure the safety of people and property by minimizing the risk of electrical shock, fire, and other hazards. When considering the installation of receptacles, the NEC specifies requirements for the location, type, and wiring. These requirements vary depending on the specific application and environment. For example, receptacles in damp or wet locations must be protected by ground fault circuit interrupters, or GFCIs, to prevent electrical shock. The NEC also addresses the use of receptacles in hazardous locations, such as areas where flammable gases or vapors may be present. In these locations, receptacles must be explosion-proof and installed in accordance with specific requirements to prevent ignition of the hazardous atmosphere. In addition to the NEC, local codes and regulations may also apply to electrical installations. These codes may be more stringent than the NEC in some areas, so it is essential to consult with local authorities to ensure compliance. When working with electricity, safety should always be the top priority. Only qualified and licensed electricians should perform electrical work. Before starting any electrical project, it is important to disconnect the power supply to the circuit being worked on. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to use appropriate personal protective equipment, such as insulated gloves and safety glasses, to protect against electrical shock and other hazards. When installing receptacles, it is important to follow the manufacturer's instructions carefully. Receptacles must be properly grounded to prevent electrical shock. The grounding wire should be connected to the grounding terminal on the receptacle and to a suitable grounding point in the electrical system. Receptacles should also be securely mounted in their enclosures to prevent them from being damaged or dislodged. When selecting receptacles, it is important to choose the correct type for the application. Receptacles are available in various configurations, including standard duplex receptacles, GFCI receptacles, and surge suppressor receptacles. The type of receptacle chosen should be appropriate for the type of equipment that will be plugged into it. For example, GFCI receptacles should be used in the areas where there is a risk of electrical shock, such as bathrooms and kitchens. Surge suppressor receptacles should be used to protect sensitive electronic equipment from power surges. In addition to the NEC and local codes, there are also industry standards and best practices that can be followed when installing receptacles. These standards and practices can help to ensure that the installation is safe, reliable, and efficient. For example, it is good practice to use wire connectors that are rated for the size and type of wire being used. It is also good practice to label all circuits and receptacles so that they can be easily identified. When troubleshooting electrical problems, it is important to follow safe work practices. Before working on any electrical equipment, disconnect the power supply to the circuit being worked on. Use a voltage tester to verify that the circuit is energized. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult with a qualified electrician. Electrical work can be dangerous, so it is important to take all necessary precautions to protect ourselves and others. The NEC Section 300.22 covers wiring methods and materials for use in ducts, plenums, and other environmental airspaces. These spaces are often used for heating, ventilation, and air conditioning or HVAC systems. The NEC restricts the types of wiring methods and materials that can be used in these spaces to reduce the risk of fire and smoke propagation. In general, only wiring methods that are specifically listed for use in environmental airspaces are permitted. These wiring methods typically have low smoke and flame characteristics. The NEC also restricts the use of certain types of equipment in environmental airspaces. For example, electrical equipment that produces excessive heat or sparks is generally prohibited. The NEC also requires that all equipment installed in environmental airspaces be properly supported and secured. The NEC Section 400.8 covers the use of flexible cords and cables. Flexible cords and cables are often used to connect portable equipment to electrical outlets. The NEC restricts the use of flexible cords and cables in certain applications to prevent damage and ensure safety. In general, flexible cords and cables should not be used as a substitute for permanent wiring. They should not be run through walls, ceilings, or floors. They should also not be subjected to excessive tension or abrasion. The NEC also specifies requirements for the size and type of flexible cords and cables that can be used in different applications. The size of a cord or cable must be appropriate for the current that it will carry. The type of cord or cable must be appropriate for the environment in which it will be used. For example, cords and cables used in damp or wet locations must be rated for wet locations. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. The manufacturer's instructions will provide information on the proper installation and operation of the equipment. It is also important to consult with a qualified electrician if you have any questions or concerns about the installation. The NEC is a complex document, so it is important to have a good understanding of its requirements before starting any electrical work. There are many resources available to help you learn about the NEC, including books, websites, and training courses. You can also consult with a qualified electrician or electrical inspector. When working with electricity, safety should always be the top priority. Take all necessary precautions to protect yourself and others from electrical shock and other hazards. Always disconnect the power supply to the circuit being worked on before starting any work. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult with a qualified electrician. The NEC is not law, but it is widely adopted by state and local jurisdictions. This means that it is often legally required to comply with the NEC when installing electrical systems. Failure to comply with the NEC can result in fines, penalties, and even legal action. In addition to the NEC, there may be other codes and standards that apply to electrical installations. For example, the International Building Code, or IC, contains requirements for the fire safety of electrical systems. It is important to be aware of all applicable codes and standards before starting any electrical work. The NEC is a living document that is constantly being updated to reflect changes in technology and best practices. The NEC is revised every 3 years, so it is important to use the latest edition of the code. The NEC is published by the National Fire Protection Association, or NFPA. The NFPA also publishes other codes and standards related to fire safety and electrical safety. The NEC is an essential resource for anyone who works with electricity. It provides the information needed to install electrical systems safely and effectively. By following the NEC, you can help to protect people and property from electrical hazards. Remember to always consult the most recent version of the NEC and any applicable local amendments for the most up-to-date regulations. If you are unsure about any aspect of electrical work, it is always best to consult a qualified and licensed electrician. The suspended ceiling, also known as a drop ceiling, is a secondary ceiling hung below the main structural ceiling. The space above the suspended ceiling is often used for running electrical wiring, HVAC ducts, and plumbing. However, the NEC places restrictions on the types of equipment and wiring methods that can be installed in this space. The NEC permits the installation of receptacles above suspended ceilings in certain limited circumstances. One exception is for industrial or commercial applications where the receptacle is permanently connected to the circuit. This means that the receptacle cannot be plugged into a flexible cord. The NEC also requires that receptacles installed above suspended ceilings be readily accessible for inspection and maintenance. This means that the receptacle must be located where it can be easily reached without having to remove ceiling tiles or other obstructions. The suggestion of using an NEMA1 box and nipple to install a receptacle above a suspended ceiling does not meet the requirements of the NEC. The NEMA1 box is not designed to be installed above a suspended ceiling, and the nipple would create a tripping hazard. A better solution would be to install a receptacle on the ceiling or use a drop cord with a receptacle. When installing a receptacle on the ceiling, it is important to choose a location that is readily accessible and that will not create a tripping hazard. The receptacle should also be protected from physical damage. A drop cord with a receptacle can be used to provide a temporary power source for equipment located above a suspended ceiling. The drop cord should be long enough to reach the equipment without creating a tripping hazard. The drop cord should also be protected from physical damage. When choosing a drop cord, it is important to select one that is rated for the amperage of the equipment that will be plugged into it. The drop cord should also be equipped with a ground fault circuit interrupter or GFCI to protect against electrical shock. The NEC provides specific guidelines for installing electrical equipment above suspended ceilings. These guidelines are designed to ensure the safety of people and property. It is important to follow these guidelines carefully when installing any electrical equipment above a suspended ceiling. The aesthetic considerations mentioned relate to the visual impact of the electrical installation. While functionality and safety are paramount, the appearance of the installation can also be important, especially in commercial or architectural settings. The visibility of conduit or wiring can be a concern for architects and designers. Some may prefer a clean, uncluttered look, while others may find the exposed elements acceptable or even desirable as part of an industrial or modern aesthetic. The tripping hazard posed by a cord hanging from the ceiling is a significant safety concern. Cords can easily be tripped over, leading to falls and injuries. This is especially a concern in areas with high traffic or where people may not be paying close attention to their surroundings. Securing cords and minimizing their length can help to reduce the risk of tripping hazards. Functionality refers to the ease of use and accessibility of the receptacle. A receptacle that is difficult to reach or use is not practical and may not be suitable for the intended application. The height of the ceiling and the location of the receptacle can affect its usability. The alternative solution of using a drop cord with a receptacle offers a temporary and flexible power source. This can be useful for applications where power is only needed occasionally or where the location of the power source needs to be adjusted. Drop cords should be chosen carefully to ensure that they are the correct length and gauge for the intended use. They should also be inspected regularly for damage or wear. The conclusion emphasizes the importance of code compliance and safety when installing receptacles above suspended ceilings. The use of a NEMA1 box and nipple is not a code-compliant solution and may pose safety risks. A more suitable solution would be to install a receptacle on the ceiling or use a drop cord with a receptacle. Always consult the NEC and local codes to ensure that electrical installations are safe and code-compliant.